Let's try to have a better understanding of different phases in machine learning. Generally, in machine learning, there are two phases, the training one and the operation one. In the training one, the objective is to estimate our model. So we input features and labels if it's supervised learning. And for unsupervised learning, as we know that we do not have labels, so we only input features. So we provide these to our training algorithm of our model, and the training algorithm will input, no, sorry, the training algorithm will output some estimation of our parameters. The parameters are the internals of the model. So what we mean by learning the model, by learning from the data, is really parameter estimation. Once we have some value of our parameters, we can enter the operational phase. In the operational phase, we have some features of new examples or new data, and we input these along with the estimation of parameters that we have. What we receive as an output of this step is some prediction from our model. So these are the two phases. One is learning, which is estimating the internal elements of the model. And the other one is using what we have learned from the training phase to do some prediction. Now let's talk about what are the elements that constitute a machine learning model. The machine learning models are composed of parameters and hyperparameters. Parameters are the internal values of the model, and they are learned during the training phase. That consists of training those parameters, and the learned value is called parameter estimate. The examples of such parameter are threshold and features in a decision tree. Here in the figure, we have an example of a decision tree. We start from the top, which is the root of the tree. We can see that at each node, we have two children nodes. Every node has a condition associated to it. Generally, we have a variable which, in the case of the first node or the root node, is temperature. And we have a threshold which is 70 Fahrenheit. We can traverse based on the condition if it is true or false. In the beginning of the learning phase, we basically have a blank template of our decision tree. We continue to fill it with conditions. At each node, we want the features associated with the conditions and the threshold. So once we have learned this, we will produce this type of decision tree. The parameters here in the decision tree are the features and the threshold at each node of the decision tree. Once we have this parameter, we can use it as we saw in the prediction phase. And with the new example, we will evaluate the values of each node with the help of conditions, whether true or false. In the example of decision tree here, let's say the root node condition is true. So we traverse towards the left, and then we will evaluate on the left child if the wind is more than 2 miles per hour. If it's less, we explore the right hand side. If it's not, then we continue to explore the left hand side of the subtree until we reach a leaf node. We can see that in the leaf node, that here we have either rain or not. And this is the predicted label, 1 or 0. As we can see, decision tree is very simple but effective model. And it's particularly nice that we can interpret it to see how the decision is made. Let's continue with parameters and hyperparameters. So, some elements of the model can be learned, but some cannot. The one that cannot be learned are called hyperparameters. Hyperparameters are the standard parameters in the sense that these are internal values that influence the model but cannot be learned. An example of such hyperparameter of our decision tree is a depth of the tree. It is a maximum possible, it is the maximum number of the nodes that we can evaluate to go to the leaf node until the end of the tree once we have a new data coming. In the example of decision tree here, we have the root node, the first layer, the second layer, and the leaf node. So the depth of the tree will be 4 or 3 depending on whether you can count the root, whether you are counting the root node or not. So we have some internal values of the model that can be learned, that is the parameters. Some that cannot be learned, that is hyperparameters. Hyperparameters are the configurable values that we can tune. We cannot say that for every data, the depth of the decision tree will be 8. For some cases, 8 will be good. For some, we want decision tree with a maximum depth of 4. If we fix the values of the hyperparameters, then the model will be too restrictive. We want to have some hyperparameters to allow our model to be different and to allow some flexibility depending on the type of data that we will train our model on. Scenario wise, we can expect different complexities. Hence, the hyperparameters are kept configurable. Let's say for spam filtering case, the task is simpler and comparatively less complex than image classification, where we may need more depth in the decision trees. Now, let's explore some topics from statistical learning theory that will help us in understanding few fundamentals of machine learning.